So module 4 starts out or is about discrete random variables. So what we're going to take a look at here um, in this module or chapter module 4, we're going to look at probability distributions for discrete random variables. There will be videos on expected value, variance, standard deviation, and then we get into the most highly commonly used um, forms of probability distributions with discrete variables, and those are going to be the binomial distribution and the Poisson distribution. So we're going to start off just by actually looking at and creating a discrete random variable probability distribution. And as mentioned in previous videos, the easiest way of looking at probability distribution is the same way we can look at, or it is exactly the same way we looked at in previous module, module 2, where we looked at relative frequencies. So just as with module 2, what we're going to do first, we're going to create a random or a variable distribution, a discrete random variable distribution for, and what we're going to use is bedroom sizes. So the first thing we want to do is we want to go ahead and create a pivot table. Our data range, I'm going to highlight everything, every set of data here. Now, I will also mention that you can actually create one of these just by entering, the outcomes and then the probabilities attached to those outcomes. But what we're going to use is we're going to use a data set that already exists. So as I said before, we're going to create using bedrooms. So I'm going to click on bedrooms and I'm going to pull it down into rows. And as you see, we have number of bedrooms 2 through 8. And down here, instead of sum, I do want it to be a count. But then this is just what we call our frequency distribution, or sorry, our frequencies. And what I'm going to do here is instead of looking at it as frequencies, I want to look at it as percent of the grand total, or what we call relative frequencies. Now, the way of thinking about this, when we talk about descriptive statistics, these are the relative frequencies that are attached to previous outcomes or previous collection of data. So in the past, 22.86% of the homes have 2 bedrooms. 24.76% of the houses have 3 bedrooms. So what this is, sorry, I guess I should explain. These are houses that are for sale in a specific market. So the price, number of bedrooms, the size of the house in terms of square footage, whether it has a pool or not, the distance from school, what township it falls in, how many garages, and then baths, how many bathrooms it has. So once again, this is what we call relative frequencies. But if we were talking about future, or what we call the other side of statistics, which is the inferencing or inferential statistics, then these can be considered probabilities. So there's a 22.86% chance or a 0.2286 probability that a house on the market will have 2 bedrooms. Okay, so that's one way of looking at. And once again, so what we use, discrete random variables, are variables that need to be counted. So with price is a measurement. Size is a measurement. But when we talk about the number of bedrooms, that's a count. We're counting how many bedrooms there are. Garages, we're counting how many there are. Bathrooms, we're counting how many there are. So these are what we consider discrete random variables. And this is a way of looking at discrete random variables, is by looking at them in the sense of their probabilities. So that's what you're looking at here, is the probabilities of our discrete random probabilities. So in once again, looking at the 2 different types of stats when we deal with descriptive statistics, which is explaining past characteristics, or we talk about inferential, which is predicting future probabilities. We also look at things in the sense of means. And they're actually calculated the same way for a probability distribution that's set up like this, in the sense that the mean would be the average number of bedrooms. But the mean would talk about the past. When we talk about inferential statistics predicting for the future, we no longer call it the mean, but instead we're going to call it the expected value. But it says the same thing. So what I'm going to do is I'm going to show you how to calculate the expected value for this, and then we're going to do it one of two ways, but it's going to be exactly how you know before. So what I'm actually going to do is I'm actually going to go down here to bedrooms, pull it down, and then down here I'm going to go to value fields. And what I'm going to do is I'm actually going to go to average, and I'm going to select OK. And what you see is an average, and this is the very bottom, of 3.8 bedrooms. So the expected value or the expected number of bedrooms that you should, a house that goes on the market, you should expect that it should have 3.8 bedrooms. Now, obviously, you can't have 0.8 of a bedroom, so we could round that up to 4. But this is the idea of the concept behind expected values. The other way of doing this would be to take a look at the average and just highlight our numbers here. And we have 3.8. So same thing, just two different ways. One is actually falling in line with the probability distribution table, and the other one is just creating the formula from scratch. So two things, two concepts here when we're talking about, I guess, a few concepts. First, a discrete random variable is a variable or a characteristic that can be counted. Once again, a price can't be counted; it's more of a measurement. A bedroom, number of bedrooms can be counted. The size of something is going to be a measurement. Whether it has a pool or not. Now, this is more of a yes/no answer. So technically, this is not the number of pools. So we're not counting and saying, oh, they have one pool. This house has 2 pools, which is unheard of. But distance is a measurement. It's in a number of miles. Township is more like a name. So it's 1 through 5, I think it is. But so that is actually not a discrete random variable. Number of garages is a variable because it is a count, and the same with bathrooms. So discrete random variables are variables that can be counted. What we call the probability distribution is the same thing as the relative frequency, and the average number of bedrooms is related to what we call the expected value or the expected number of bedrooms. Okay, so once again, just looking at that relationship. If you have any questions on these general just pieces of information about discrete random variables, please feel free to reach out to me.